Podcast is now starting. All attendees are in listen-only mode.
Hello everyone, and thank you for attending today's webcast, Autodesk Inventor using Custom Sections with Frame Generator, presented by Forrest Judd, Solutions Engineer with Hagerman & Company. We also have Gary Bergero, CAD Training Manager with Hagerman, on the line to assist with your questions. This presentation is being broadcasted in listen-only mode. You can ask questions by typing them into the question section of the GoToWebinar control panel on the side of your screen, and Gary will address your questions throughout the presentation. At the end of the broadcast, when you exit GoToWebinar, you'll be prompted to fill out a short 3-question survey. We ask that you take a few moments to provide us with your feedback. Also, all attendees will receive a certificate of attendance and a link to the recording of this presentation. Forrest, whenever you're ready, you may begin.
All right, thanks, Brina, and thanks everyone for attending this morning. I hope you find this informative. Just a bit of review for what Brina mentioned. Well, I'll get to that in a second. I guess we should talk about our agenda. We're going to be talking this morning about using custom shapes and custom cross-sections with Frame Generator. Inventor's Frame Generator is really a great tool if you've got to do any sort of framework, like table frames or guards, things like that. But there are a lot of shapes in the world that aren't in the default libraries. So it's important that you know, if you're going to use Frame Generator, that you know how to add your own sections. So that's what we're going to discuss this morning. We're going to talk about creating custom sections, then publishing those to the Content Center. I'll do a quick review of the Frame Generator functionality for those of you who aren't very familiar with it. We'll discuss modifying the Content Center, which I find is something that if you're going to use the Content Center in Inventor, you absolutely need to know how to do it, but many people don't, or they're just not comfortable with it. So we're going to talk about that. And at the very end, we'll have a short review of the Inventor's Frame Analysis functionality that's built into Inventor Professional. So if you need to do any sort of virtual testing of your framework before you build it, Inventor can help you with that. And then we'll have some time for a dedicated question and answer at the end of the presentation. So just as we go, feel free to ask questions via the questions pane at any time. Gary may answer those questions as we go via text in the question in the answer pane itself. I'll be keeping an eye on them too, though, so if a pertinent question comes up, I may address that as we go through the presentation. And also, this presentation is being recorded, so you can watch it again later or share it with your colleagues. Here in sometime in the next few days, it will be available on our webcast on demand page on our website. If you've never been to this page, it really is a great resource. We have a ton of previous webcasts all available here: data management, AEC, manufacturing, just a huge list, tons and tons of great content. So if you've got a few minutes, you might check that out and see if any of the topics apply to something you need to learn about. So with that, we'll get started with the presentation. We're going to start out with a discussion of how to create custom sections. There are lots of ways you can do it. There are kind of good ways and I want to say bad ways, but maybe less productive ways to do it. We're going to cover things like proper parameter use, making sure that you name your parameters appropriately. I'll show you how to author a section. We'll discuss special notch profiles, which for more complex sections can be important, and then mapping your parameters so that both your Frame Generator use of that section and maybe in the frame analysis environment are both successful. So one of the most important elements of authoring a custom section will be to use parameters intelligently. They need to have appropriate names so that it's easier for you later on in the authoring process to specify what's what. Some of the key parameters you're going to need for any section will be a height and a width, a thickness if the section is thin-walled, and then one that's absolutely required is going to be the length. Ultimately, it's going to be the length of the member when it gets either used in Frame Generator or placed manually from the Content Center. When it comes to authoring, you're actually almost always going to want to create an iPart out of the section before you author it. That's going to make it easier to use straight out of the Content Center, and it's also going to give you an opportunity to provide some additional like property information up front. If the section is something that's going to be variable size, let's say, for example, you want to use square aluminum tubing, I don't think there's actually a library that comes with the Inventor software that includes that. You can build the different sizes of aluminum tube into the same Content Center family and use it just like you would any of the standard shapes. You're going to want to create an iPart out of that, and add at least a few sizes that you're going to use, maybe right into the iPart. And then later on you can add additional sizes in the Content Center. We'll be covering that a bit later. So once you've got it made into an iPart, then you would go into the structural shape authoring tool, which is where you supply all the information needed to use this shape with the frame generator. So its base point, the category that it belongs to, which is going to determine what parameters are associated with it, of course the base extrusion, what the shape is, but also a special notch profile. Now the notch profile is used specifically with the notch end treatment, which if you're not familiar with that, we'll discuss that in a little bit. But ultimately it's where you're cutting a shape from one member as relief, almost like coping against another member. By default, it's going to cut line to line the exact shape of the member. So you can see, in this picture here, on the left, say we're using a piece of extruded aluminum, the cutout is extremely complex, and odds are you don't really need that shape cut out if it's just maybe a pocket for this to sit in on a beam. Ideally, you'd want to cut out maybe just more of a rectangular shape. The special notch profile allows you to do that. Not just for that, but even if it's a simple, if you're the member you're cutting out to cope against, even if it's simple, Inventor still does line to line. So if you're going to do welding, if you're going to weld this together, you may need some additional clearance in there. The special notch profile would allow you to introduce that clearance. So they can be very useful. And finally, you would do your parameter mapping. This is going to make sure especially that the frame analysis module will work. Most of our structural shape categories in Content Center have all of these special parameters built in. You don't necessarily need to fill out all of these. When we get into the frame analysis module, I'll show you that it does calculate the vast majority of them. But especially if the shape you've drawn is maybe simplified, you may need to, I guess, override whatever Inventor might calculate with these values. And so you'll ultimately need parameters, either model parameters or columns in your iPart table. That's why it can be important to convert this thing into an iPart, even if there's only a single size, because you'll want to map iPart table columns to these various category parameters. So let's take a look at how we would actually go through this process. Now I decided to use, for this example, some extruded aluminum shapes. This is something that when I was doing machine design every day, I used a lot of 80-20 components. So it's just a T-slotted aluminum, similar to Unistrut, or item is another common shape just like this. And they have lots of different cross sections. This is something I downloaded straight from the 80-20 website. It's the 45 series family. And I can use this part to start with to create my shape. Now, I ultimately need some parameters to specify some of the, to map to some of the category parameters. the model from 80/20 is just a sketch. There are actually no dimensions. So I am going to put in a few parameters here. We're going to call this the width, and we'll just make sure, let's keep it at 90. I could go in and dimension every little bit of this, but there's so much geometry, so we would need, several hundred constraints or dimensions. And as long as we don't change these values, then we're in good shape. So this is the height. I'll go ahead and put a thickness in here. And you can ultimately call these parameters whatever you'd like. I'm just using height and width and thickness because that's going to be most analogous to the category parameters that I need to specify. And there's already an extruded feature here, so I'm just going to modify that. So if you've never done this, use this process to name a parameter for it. Just to note, you can type in the name and then equals and then whatever value. And that can be easier, especially if it's a model that someone else created, than going to your parameters page and trying to figure out what D0 is and D1 and D2. You can go right there while you're editing and give them appropriate names. Okay, so I've got a few parameters to work with. At this point, I think I'll create an iPart out of it. Even though this is just a single size, I'm not going to try to get fancy with this and include all of the sizes and the different geometry into one. Ultimately, I could if I got really fancy, I think, with the geometry, but in this case, I'm not going to try to bother with it. So one of the things I'm going to do, the width, the height, and the thickness ultimately are not going to change, but the length of this is going to be variable. And if I create a custom parameter column out of the length, when I then publish this to the Content Center, it's going to make it easier for me to use even in the absence of Frame Generator. So if I don't want to use Frame Generator and I just want to have this custom section in my library to put down one by one and type in a length, I can do that. I'm also going to set the width and the height as key columns. This is going to make it easier for me to select when I actually use the Frame Generator. And we'll talk a little bit more about that later. So I have a single row here. That's all I needed for this case. You can always put in, it might be a good idea also to put in some things like a stock number and maybe a part number. Well, I guess the part number is already there. So that if you want this information to come out onto the parts when they're placed, say for bills of material, that you have that already in place. Like description and stock number might be good, right? So the description might be, 4590 series 8020 extruded aluminum. And then maybe, whatever this is, 8020-4590. So now we have an iPart with a single row, and that's just going to make it easier for when we go to author. Now, if you've never done this before, it might be kind of hard to find the tool. It's just a little unassuming button up here called Structural Shape. And you'll notice we have various authoring tools depending on the edition of Inventor that you have. We could author components for use in the tube and pipe environment or for the wire harness environment. In this case, we're looking for structural shape authoring. You always start by selecting the category that this is going to go into, because we have some predefined categories for our steel shapes like angles and channels and I-beams. I'm just going to put it in Other for now. You can ultimately add your own categories to the library. We'll talk about that just shortly when we get into modifying the Content Center. It's going to select the base extrusion by default. It's going to select the origin of the part as the default base point. So that means when you create your own sections, you're absolutely going to want to create the geometry around the origin of the part. And one thing I forgot to do in the original sketch was create geometry for the notch profile. Because I don't want, if I cut out a notch with this, I don't want, this complex shape cut out. So I'm going to go back into my sketch, and I'm just going to create a center point rectangle right on the middle, right there from the center. And we'll give a little bit of clearance here too. So we'll do like the width plus 1 millimeter and the height plus 1 millimeter on the outside. And then we'll round the corners off. So this is going to be the shape that ultimately gets cut out. Now you notice I'm making this on the same sketch as the shape. It needs to be in your base sketch with the rest of the geometry. So now when I author this shape, and I choose a notch profile, you're picking, and this is going to be, there are going to be several clicks involved here because there's so many different regions, and the geometry is pretty complex, and so it hesitates a little bit when I pick. But this is just like if you were picking a region for extrusion. And you can see the preview is going to show here's what the cutout's going to look like. And I just want just a nice simple rectangle with rounded corners. So if I use the notch command, this is going to be the shape that it cuts out. So the last step here is to map the parameters. The table columns you see here, this is going to be where you can pick from your IPart table. So we had length, and then shape height was our height. And so because I've named these parameters, I can quickly and easily set those. Now, I'm not going to bother setting any of the other parameters just yet. I could if I wanted to, but Inventor will figure out most of these when necessary, especially like in the frame analysis environment. And just like that, the part has been authored. Now, I personally like to take this shape that I've made now. It's ready to be put in the Content Center. I like to save this and maybe even put it into my vault at this point, so that if I ever need to get back to it, like if I needed to completely republish this part, I could. So we'll do 4590 with authoring. That way I just have it handy if I need to get back to it at any point. So you can see it's pretty straightforward. If I had multiple sizes to this part, like the width or the height or the thickness needed to vary, I would just add additional rows to the IPart table to accommodate those sizes, modify the values, and then eventually when I publish this to the Content Center, it's going to extract that iTable information into the family table of the Content Center. Right, so the next step in this process is publishing it to the Content Center. So some key elements to this: you're going to need a custom Content Center library. You're going to have to confirm the category and parameter mapping. Because we authored the part, that's going to mostly be done for us in this case. You'll need to specify key parameters, and you'll need to fill out some information about the family, like the standard organization and a description of the name. So of course the first step to publishing anything to the Content Center is you must have a custom library defined. Now with a default installation, if you don't uncheck any boxes or make any changes to the configuration during Inventor installation, your Inventor will be set up to use the desktop content libraries. These are just sort of databases that sit by default on your computer. All of the standard libraries are there, and you have one custom library created called My Library. Now, if you're using Vault, you also have the option to have those libraries hosted on your Vault server. So we take a look here in our application options inside Inventor on our Content Center tab. This is where you indicate whether you're using Inventor desktop content or your Autodesk Vault server. Now, as far as the defining what Content Center libraries are available to you, that is controlled by your project file. So if we go to our projects dialog, I'm working in my Vault project currently. So you notice I can work in a Vault, as much as I want, and I don't have to use the Vault for my content libraries. In larger groups, I like the idea of using the Vault to manage the content because everyone uses the same libraries that way, and they're always just available. If you're in a smaller group, or if you don't need to share your customizations amongst other people, or maybe if you travel a lot and work with Inventor while you're traveling, you may want to go the desktop content route because you may not have a connection to your Vault while you're traveling, or if you're connected via VPN in a hotel room, like I often am, the connection can be really slow, and it can get a bit frustrating to use Inventor. Right. So whichever route you go, you've specified the libraries that are available to you via your project file. Now, your project file has to be read-only, or read-write, I'm sorry. Mine currently is not checked out to me. So if you're in a Vault environment and you need to modify this kind of thing, you will need permission to check out your Vault project file. And this frequently happens as well. Inventor likes to lock down that project file. I'm doing all this on purpose so that you can see what you might run into if you have to do this yourself. Right. So now that this is read-write, I can go and look at my content library configuration. And this is going to tell me right now I'm using my Inventor desktop content. This is also an easy way to find where the libraries are stored. Again, this is the default location in your program data folder. And you can see I have some of the libraries available, but not all. And I do have a read-write library available. So all of the default libraries are read-only. You're not allowed to modify those directly. Now, if I'm using if I'm using desktop content, I should say, this is how I would create a new library, is through this configure libraries. Press the button, give it a name, so my custom library. And just like that, we have a new library to which we could add. That's if you're using desktop content. If you're using the Vault, you have to have access to, well, I say that, but you have to have you at least have to have permission to create Content Center libraries on your Vault server. Right? So if you say I'm using the Vault for my content, we're going to see a slightly different look here. So now that I'm using my Vault server, you can see I actually don't have any libraries at all on my server. And if you notice, I don't have the ability to create a new library if I'm using Vault here. To do that, you have to use your data management server console. So this is an application that's on the server, and to create a new read-write library, you just right-click on your you log into your console, right-click, create library, and that goes through the process of making the database on the server and making it available. Now with that library available, you can see I could put it into use, and now I would have one on my Vault server. So it's a slightly different process, but ultimately that is the first step of customizing your content centers. You have to make sure that you have a read-write library available. Right, so once you've got a library there, then you can actually get to the publishing part. So you would start out by choosing the category that you want to publish the part into and mapping your parameters. Now, if you have used the structural shape authoring, this part's easy. All those choices are actually made for you. You'll then want to specify your key parameters. Now, for structural shapes like this, length is always going to be one of them, and you always need at least one other parameter. Even if your part is just a single size, you're going to want to pick one more parameter at least to define when you use in the user interface so that you know what you're picking. You could choose the height or the width usually. If your shape is variable in size, you're going to want to pick enough key parameters so that you can completely define a specific row of the table. So if you have variable, width and height and thickness, let's say. If you have aluminum tube, let's say you have a 2x2 by 1/4 inch thick and a 2x2 by 3/8 inch thick. You need to have the thickness and at least one of the other two parameters as key parameters so you could correctly indicate, I want this version of the tube at this wall thickness. And then finally, you would pick a standards organization and the description and the name of it. The standard organization is how you're ultimately going to easily locate this custom shape that you're making. So what I like to do, even if it's a standard, like if there's actually a standard like ANSI or DEN, I like to provide a custom name so that I can very easily find my custom shapes. And I'll show you that here in just a second. So let's go back to the part that I just authored. To put this into the Content Center, once it's been authored, I go to my Content Center tab, or panel I should say, and just press Publish Part. Now I have to choose the library to which I want to publish. We'll use my library. Now because I authored this, the category is already selected for me. I could choose another category here if I wanted to, but then I might have to adjust my parameter mapping. On the next page, this is the exact same screen that I saw when I was authoring, so I've already done the parameter mapping. If this was a part you didn't author and you were just putting it into your Content Center, you would do the mapping at this point. Now the key columns that I had added in my iPart table get automatically included. I'm going to make sure and put the length in there as a key column as well. The order you see here is just the order in which they're going to be in the UI if you were to place it manually. Now in this case, because I only had one row in my table, the file name column is not going to, and because I've got a custom length here, the file name of the part when it gets placed isn't necessarily going to be unique. We'll talk more about this when I get into modifying the Content Center, but if I plan to use this part aside from the frame generator, I may want to go and modify the family table so that the file name, when I place it, always comes out to be unique. We'll talk more about that in just a bit. So this is basically the last page. The family name and the description, you see the description came out from the description column of my iPart table. Now standard organization, you can see here, it's got a few defaults. I can actually type anything in this field that I want, and it's just basically going to add a new standard organization to this list. So I could call it 80/20 custom, for example, and that'll be a new standard organization. I'm just going to pick 80/20 because I want to keep all my 80/20 sections together. Now the rest of these you could choose to you know, fill out or not. And then the last page is just the thumbnail. This is what you're going to see in the Content Center UI. I do see one question came in that's pretty relevant right now. The why would you map? I think meaning when you publish the part, why would you map parameters? Some of these parameters are necessary for the frame analysis environment to work. So if you needed custom, say if let's say I was drawing this shape, but I didn't want to make it so complex. I could simplify this by maybe just putting in just a circle as opposed to this complex shape. But then the moment of inertia and section area and whatnot that Inventor would calculate when I'm using the frame analysis module wouldn't be correct. So I may need to override that by providing the actual, mechanical properties of the section. So that's maybe why I would map those. We have to map length. It may be hard to tell over the GoToMeeting, but this the base length parameter is actually required. The background is like slightly cream colored versus the rest of them are just white. So in the case of structural shapes, we have to map a length. The rest of them are optional. I just find it to be a best practice. So just like that, now our part is in the Content Center. And if we were to start a brand new assembly, just go to Place from Content Center, we would see in our Structural Shapes Other, we do have that new shape. Right? And if I double-click to place it, I can choose based on width and height, and then I could type in whatever length I wanted. And this is what I was talking about with the file name. This is going to be the name of that file that comes out by default, regardless of the length that I put in. So without any changes to the Content Center, I'm going to have to be pretty careful when I place these shapes to maybe name this thing uniquely, say with the length that I typed in. I'll show you here in just a minute how we can customize the Content Center so that the length gets added in automatically. So just like that, now I have a piece of extruded aluminum in my Content Center that I can start making frames with. All right, so let's talk just a little bit about the frame generator now. I'm not sure how much time I want to spend on this. I'm going to ask everyone a question just to get an idea of what the experience level with frame generators. So if everyone could just take a second and answer this question. Basically the question is, have you ever used or do you use Inventor's frame generator functionality? Basically, have you never used it? Have you used it a few times, or do you use it a lot? I just want to get an idea of where we're at here. Thanks everyone for voting. We're getting quite a few votes. This is nice. Okay, so most of you have voted now. It looks like about half the group has used it a few times. About a quarter of the group uses it very frequently, and a quarter of the group has never used it at all. So I'll go through this kind of quickly. There are lots of resources online for using the frame generator. The help is really good. So let's just kind of go through this quickly, since most of the group has used it, at least a few times or use it frequently. So I'm going to talk about creating your skeletons, adding members, the Intruments, and then there are a couple of new things in 2015 that you may not be aware of. When you're using Frame Generator, you're generally going to start out with a skeleton. Now that's going to be a separate part file that contains edges that somehow define member locations, be it the center line of a member or maybe the top left corner. Those edges can be center lines now in 2015, or say an exterior edge of the shape that you're going to place. Also keep in mind that just because your frame is 3D, it doesn't mean your sketches have to be. It can be difficult to sketch in 3D in Inventor. If you've got a lot of practice with it, it's not so bad, but there's no reason that you have to use a 3D sketch to create a frame unless you're making some crazy curved member that requires a 3D sketch. But if you're sticking with just straight members, like you're actually building just a frame out of it, you can build up your skeleton from a series of 2D sketches. And when I do that, I like to use projected geometry across the sketches to make sure that if things are symmetric, they stay that way, and to simplify changes to the sketch. Right. So once your skeleton is done, then you would go to add members. So any edge can be used to specify a member. That's a sketch edge, say, in your skeleton, or even the edge of an existing part, like another part. So let's say you have a table, and you want to put a guard on that table out of this extruded aluminum. You could pick the edge of the table and say the edge of the table is actually defines the lower right-hand corner of the shape. And that will let you use the table to lay down the members, so you wouldn't necessarily have to have a sketch to use it. Construction lines can be used now in your sketch, in your skeleton. Now, by default, every edge you pick is going to result in a separate IPT file. So even if, let's say you had a 3 foot by 3 foot cube by 3 foot cube frame, even if a lot of the members are exactly the same length, every edge you pick is going to be a separate IPT file. That does lead to maybe some headaches here and there when you're managing the files. Now in 2015, they've now added the ability to reuse members. I will show you that specifically, since that's new in 2015. You can select multiple edges when you make these frames. You can control the offset in both directions from the edge, and rotation. You can mirror the components. So there are lots of ways you can leverage the sketch that you made or existing model edges to build this frame. You don't have to sit and figure out for every member where is its center line and draw it just right. You can get it close, and then if you have to tweak its location, you can do so. Now when we put in these members, what you'll see is they're all going to overlap, right? We're just starting out, we're roughing out the frame, and then we ultimately determine how the ends meet up, right? We can do miters, we can do notches, we can sort of trim and extend members, ultimately so we can clean this frame up, and then ultimately get exactly the shapes that we need so we can detail them, or so that they come out the right length on a bill of materials, let's say. Because like I don't know if you use extruded aluminum frames, my experience has been sometimes we would use like the bracket hardware to fasten things, but as often as not, we would actually counterbore through one member and then tap the center hole of the adjoining member and just screw the frames together, as opposed to using the mounting hardware. I mean, it saves a little bit of money if you've got guys that can quickly drill and tap everything. So in that case, we would just order a bunch of straight sections to length, not do any fancy miters or anything. So we just have a cut list. If you do your Intruments right, the cut list just sort of falls out of as a result of doing all your Intruments. right? Now, one of the big new functions for Frame Generator in 2015 is the ability to reuse members. This does a couple of things. It simplifies the file management, but personally I think, especially if you're using Vault, that's not the real benefit. The benefit is if you've got parts that really need to be the same, if they are symmetric, if their end treatments are the same, and if you're adding some special features to them that need to be the same, you can reuse those members, modify one part, and just like a normal part that you'd reused, the changes impact all instances or all occurrences of that part, right? A couple of notes about it: any end treatments you apply will always be applied to the parent member, and then they will carry over, of course, to the children. Now you can control the offset, rotation, and mirror of the reused components. So especially if they're not necessarily symmetric but mirrored, you can work with that, right? So I'm gonna pull out a version of my assembly here. I'm not going to bother creating the skeleton because I think most people, if you've taken an interest in this webcast, you probably at least know how to make some sketches. I'm going to fetch out a version of my assembly that has just the skeleton. All right, so I created a skeleton here. You can see if we look at my skeleton part, this is really just a series of 2D sketches, various work planes. Right, and then to use Frame Generator, I just go to the Design tab and Insert Frame. Well, you can see here's my 80-20 standard. I have my 45-45 and my 45-90. I published this one yesterday. This is the one I just did this morning. So this is my 90/45. If I had not selected as key columns my height and width, then I would have something here that would just say unnamed 1, for example. If you notice my 45-45, the size is just 45 because that's why I picked, just a single parameter for that. So if you're publishing your own members, always add at least one additional parameter from your iPart table to your key columns when you publish. Otherwise, it's going to be hard for you to know exactly what you're getting here. So let's say I'll pick my size. When I pick an edge, notice how it's placing this down onto the frame. I get a nice preview of it. When I create the frame, it's going to make a new assembly file, right? And a new skeleton as reference. You're going to want to make sure that these things get named uniquely. Usually, with like something related to the project you're working on, or the job number, order number, whatever it might be. Now this is the one element of Frame Generator I think is just a bit frustrating. The name of the individual members ultimately comes out from some combination of like the file name from the Content Center, and then it's going to tack on this unique number at the bottom, at the end of it. The thing is, this number comes, it's always the same, so if it's a, a 2x2 square tube, like some ANSI tube, if you use that in frames across like everything you do, you're going to have a lot of similarly named files across all of your jobs. So what I like to do, this is one of the reasons I really like Vault, because I can check this thing into Vault and then use rename once it's in Vault to make them unique. So that's a question we just got. Any tips on managing members and enforce unique file name in Vault? Right, and if you use this functionality a lot and you use Vault and you follow the best practice of making your files uniquely named in Vault, this can cause you trouble. So what I like to do is when I put a new frame into Vault, I immediately use the rename functionality to rename the files in Vault. That way they become unique so that the next frame I put in, it'll go in without any trouble. Otherwise, you have to come into each file and try to give it a new name. I'm sure somewhere on the idea station is a request to like do a replace or a, other boxes like this. We have the ability to put in a prefix or a suffix on the file name. And we don't have that here. Ultimately, I think it might be coming. So just like that, now you see the members are getting placed. It's pulling out the members, and there we go. This thing is complaining at me because I don't have it checked out, so we're going to check it out here. We're getting really short on time, so I want to make sure we get to some of the other things. So just to show you quickly how we might do Intruments here, I can always miter. And it will trim one against the other, so that's really nice. About the reuse, so let's say that I take this member here. If these really are going to be the same, these two, I could choose reuse, and I could say that's the member I want to reuse, and I want to put it over here. So just like that, they're now the same model file. But you notice what happened. The miter that was on the original, of course, carries over to this one because they're the same part file. But it's flipped the wrong direction. So what I may ultimately need to do is either mirror or rotate. Let's just try 180 here. Unfortunately, you notice the preview that I get, I don't see the miter in the preview. So you may have to guess a little bit when you use reuse, but ultimately that now does the trick. Now I can come back and still miter this against that. It's not going to apply a second miter to this member because it's the child, but it is going to miter this unique member up against it so that it'll work out. Okay, so I'm going to leave the frame generator stuff there since most of the group has actually kind of used it before. So let's move on to modifying the content center. And I don't know that we'll necessarily get into the frame analysis part. That was kind of an extra if we had time. But I want to make sure we spend a little bit of time talking about modifying the content center because this is something that a lot of people don't understand well or don't know how to do, right? So we're going to talk about modifying custom library files, modifying your family properties and your family tables, how you handle materials with the Content Center, and then finally updating family templates. Now one thing that if I've not touched Content Center for a while, sometimes I have to remember this, like how to do this particular thing. And it comes with when you want to modify your library files themselves. When you edit your Content Center, if you go to your Manage ribbon, the Content Center editor is right here. By default, you're put into what's called a merged view. And when you are in a merged view, you see the contents of all libraries kind of stacked up together. And you're going to notice some of these files have some of these categories are like light gray, some of them are yellow. Anything that's in lightly colored, that's read-only. You can't change that object. In addition, I have no ability to add new categories. I can change the category properties of some things, right? But I don't have a whole lot of functionality here. If I switch my library view, however, to only show my library, granted I only see the contents of my library, but now I have additional capability. Like I can now create a category here, right? Or I could, copy a category. I could move this thing around if I had another library to move it to. So some things you may need to switch your library view to specifically view your library. Right. So one question we got, can you rename a custom category folder inside the Content Center? This is how I would do it. So that is renamed, but if I go back to my merged view, we still have, well, you know, I say that, but it actually now is called My Other Parts. So even though the other libraries had a folder called Other Parts, when we look at our merged view, and by default when you're placing from Content Center, you're always going to see a merged view. You know, this is how I would do it. So if you want to rename any of these categories, you might first need to copy that category to your library. And then once it's in your custom library, then you could modify. Now keep in mind, if you copy the category, it's going to copy all of the contents of the category. So if you do that, say, with the fasteners category, it's going to take you a little while, and it's going to take a long time, actually, and your custom library could get very large. So be careful if you try to do the entire category. If you do just a single member, like come in here and grab just this bearing, right-click, copy to My Library. This is how you would modify a Content Center, a default part. Now that category is here, and I could change the name of the category at this point. So, but remember that library view. You may need to switch to your specific library to make some changes. Modifying families is what you're going to be doing most of the time. You're not usually manipulating the library all that much. Now some things you can do, and we're going to use the specific example of this 4590 that I published. Right-click, Family Properties. This is where I could change the name or the description. This is also where I could control the parameter mapping. Remember that same thing. Now we can modify it. Or the thumbnail if I don't like the way the picture looks. As far as the table goes, this is how you specify properties, properties, parameter changes, add new members. One of them is the file name. If you remember, when I put this thing, when I placed from the Content Center, the file name that came out was just, basically this part number, right? If I want to modify the file name so that it's unique by default based on the length, I need to modify this column. And what we can do is, any of these columns can be an expression. We can add together multiple columns here. So if this is going to be my file name, I want the member name as the root, and then maybe I want to tack onto the end of it the length. So I can insert the length here. And so now, rather than it being the same every time I place, it's going to tack on the length of the member that I put in. So now my file names will at least start out unique based on length. We can add our own columns here, and we can map this column to various properties of the document. So if we want our our cost center to be filled out for Content Center parts, we can do that. Or the big one, especially with fasteners, is the part number, because they have this generic, bizarre part number that nobody actually uses. You might need to change this, or you could add your own column with your own custom part numbers, and then just remove the mapping from this column and apply it, say, to maybe the stock number column. We could map this instead to project.part number, right? So any of these columns can be mapped. There was a question here, would that be an approach to making custom tube sizes, for example? So yes, if let's say that one of the big ones I get all the time is aluminum tubing. So if we do have like steel tubing. If you're okay with having the rounded corners and you just kind of want to make an example of it, but you need to modify the thicknesses and whatnot, you can always copy to your library. Now that it's here, I could modify the family table, and I could tweak the individual sizes to match what's basically aluminum tubing. I'd also want to modify the material, of course. All right. That gets us into materials, right? Because some of these things, some components, especially our fasteners, I think they might start out with mild steel or whatever. Well, if you want to be able to specify stainless steel screws or aluminum or different materials like stainless steel, well, I guess we've got some stainless steel tubes already. But if it's a custom part that you've made and you want to be able to specify multiple materials, material is ultimately a column in that table, right? So you have to specify what the material is. Now, if you want to have different materials for different families, you can do that in a couple ways. One, you could introduce a column for material, and then you could have all of the material variations in the same table. And so you go through all the mild steel ones, and then you have another 73 rows for aluminum, and then another 73 rows for stainless. The other way is to make a whole new family where all of these things are the same and just the material is different. Now, there's something to help you with that. It's something called the material guide. This is sort of a wizard that walks you through and say, do you want to create a new family for each material, or do you want to add new rows? Right? So we'll just add new rows to this family here, and we're going to add, let's say, we'll just do stainless steel. And if there are existing materials in the library, you can take them back out, right? So this is a good way to just kind of duplicate all of these things. And it's going to go through and add a whole bunch of new rows to the table. So now we should have 146 rows, where some of them are stainless steel and some of them are mild steel. Right? Because this is especially important with standard content center shapes that you can't modify once you pull them out. You need to specify the material when you select them. And this is a good way to make that happen. So usually with your fasteners is where you're going to want to do something like that. And we're just about out of time. I want to talk about modifying templates. If you need to modify the actual geometry here. So let's say that when I published this part, there was a problem with the geometry. I don't have to republish it. I can modify what's here. I would ultimately need to place at least one copy of this guy. I can't start with what I published from. I would need to place this somewhere. Then I would modify that part, and then I can replace family template. And that lets me point to that modified part, and it will update the geometry, not the rows, right? None of the row definitions, just the geometry. You want to avoid removing any parameters that were there, though, because if you do that, it's going to invalidate the family, and you might have to republish it at that point. All right, and we're basically out of time. I just want to talk about just some things you can do with frame analysis. You put the frame together, especially with Frame Generator, it will automatically figure out how, like, joints for all of the members, how they get connected. And then you specify the beam properties. Most of those come from the shapes themselves. Specify materials. Much like a general FEA analysis where you have to say, how is this thing constrained and how is it loaded? You do all of that. The thing is, if you use something like frame analysis, it's much, much faster than a traditional analysis. Because if we're looking at a shape like this, if I'm going to do a traditional FEA analysis on this part and it's very long, let's say it's, what are we looking at? Where's the length here? 500 millimeters long. If I'm going to mesh this with like a traditional FEA analysis, the elements are going to have to be really tiny to do a good analysis on this. Whereas if it's just just this member, if we know its sections, we can actually do a different analysis type that's more math than anything, mathematical, as opposed to like discretizing the solution. And that's what the frame analysis does. So the result is the thing solves much, much faster than just like an FEA analysis. We can still get things like deflection, natural frequency, which can be really important. Normal stresses, we can get, bending diagrams. Let me just pull out this, because I do have a finished version of it. Let's see here. Just so you can kind of see what the results might be like. All right, so we're in our frame analysis module, so you can see, we have access to all of the beams. It determines how things are connected. You can control the joints, so if they're not rigidly fixed, if they're kind of pinned together, if they can slide against each other, you can specify all of that. And just like, the other analyses, you can, adjust the way the deflection looks. You can, animate the deflection, so you can see it actually, how this would deflect based on the loading. And it solves very quickly. It's very easy to use. So, and with that, I think we need to wrap it up other than just questions. So I think we've had a few questions come in so far. A couple we've yet to address. So let's see. Right. If you don't use Vault, could the custom content center be put on a server to share between designers? Yes, Gary did address that. Yeah, but ultimately you can put your libraries, your desktop content libraries on a server, and then point your project file to that location. The recording of the webinar is going to be at, here in a few days, hagerman.com/events/webcasts on demand. If you want to get to it from just the root site, if you go to hagerman.com, you can click on Events, and then Webcast on Demand right over here on the left. Another question. I have an assembly that I have created that doesn't use any frame members. The assembly gets used on a frame. How can I make it so the assembly is seen in the frame assembly, since the assembly does not add a significant amount of strength to the frame? So I'm assuming this is for the frame analysis environment. I think ultimately what you would need to do, the way I think I would take care of that, because you can only, if it's not a frame member, then you can't, there's no way of representing it in the frame analysis environment. What you could do, however, is you could add what are called rigid links. So ultimately, if it's just adding stiffness, so like in this case, we can see in this part, it's not very stiff, right? It moves quite a bit because these big open areas. If I was putting like a big plate, if I was going to weld a plate on this corner, ultimately what I'd be saying is, especially in this configuration, it's almost like taking a point here and rigidly affixing it to a point over here. It's not really going to flex much. So the way I would do that is I would add a couple of custom nodes, say right there, wherever the extents of the plate would be, there, and then I would add a rigid link between those two nodes. So ultimately it's providing stiffness between those two, almost like if it was a gusset, but I don't actually have the gusset on there. And now if I run the simulation, this will show you how fast it is, right? So now I'm getting significantly less flex in that corner than I would otherwise, because I'm saying that those two are fundamentally attached. So that's how I would approximate it. Let's see, an earlier question from Joseph, when using copy design function in Vault, why does Vault convert a frame generator assembly from a weldment type IAM to a standard Inventor IAM? That's a good question. My guess is it may be using, I'd really have to look at that, Joseph. We might have to get an answer to you. I never really noticed that before. I guess I never go so far as to convert my frame generator assemblies to weldments. The only reason I can think of that it would do that is if it was actually using a template to rebuild the assembly, but that doesn't make sense. So it may be something that they specifically decided to do, is to change it from a weldment. I'm going to make note of that, and I'll get back with you if I can find out why. My guess is, though, you can't necessarily change that it does that, unfortunately. The question is, can we add a gusset in the frame so it sees the rigid constraint in the frame? You could put it on there, but it's not going to recognize it in the frame analysis environment. It's only going to recognize basically authored structural shapes. So if it was like a plate gusset, now if it's a tube, sure, as long as it's a custom, like if you publish it to the Content Center or authored it. But if it's a plate, you have to insert custom nodes and do a rigid link that way. Ultimately, I think the reason this didn't necessarily get so well tied up, if it was around this entire corner here, yeah, I think you would try to tie these three together as opposed, so you would tie this one to the parent up here and then tie that one to that one. That's how you would do if it was a gusset, because ultimately you're saying that these nodes aren't allowed to move relative to each other, adding rigidity to the frame. Any other questions? Question, if sharing Content Center files between 10 designers on a company server, will I experience a significant slowdown of loading versus the Vault method? My guess is no. People are going to be hitting those files somewhat infrequently. I mean, unless all 10 people did nothing but place content all day, I can't imagine that you would see a significant difference in performance one from the other. They've optimized the Content Center pretty effectively too. It caches a lot of data, so I don't think you would have any problem. If you have 10 designers and you're not using Vault, Vault probably has a lot of benefits aside from the Content Center stuff. But if you are using Vault and you just want to use the desktop content instead of the Vault server, I don't see any drawback in using just the desktop content for a group that size. Any other questions? Can you have multiple frames in one assembly? Yes. Each time you choose to insert members, I believe it will, well, I believe, actually I think it's going to put them all in the same frame. You would have to like make it in a different, I think in a different assembly and then insert it. You might want to make it in a sub-assembly, I think would be the way you would do it. Okay, well, I think we'll wrap it up there. I'm going to get back with that one answer to Joseph about why it strips the weldment property out. Otherwise, thanks everyone for attending. If you'd like to review this webcast, don't forget it will be available on our webcast on demand here in a few days. And good luck with Frame Generator. Thank you. Bye-bye.